change the system. Okay, so please let me know.
Dear participants, I would like to inform that in every session we have quiz and feedback. We will provide the quiz and feedback link in between or at the last of the session, and the attendance and the marks of quiz are according to the participant. You have participated in the quiz and the feedback. So please don't forget participate in quiz and give the feedback. Thank you.
Hello.
Yes, sir, you are
Hello.
audible.
Okay, thank you. Sorry for this delay. Actually, there is some issue with my system. Okay. Good morning, everyone present here. Today, I will discuss as the organizer suggests and assign me a topic: introduction of artificial intelligence, machine learning algorithms, especially supervised machine learning algorithms. Although they have assigned me unsupervised also, but it will be in 1.5. It will very difficult to cover all these things. So I just start with the introduction. Okay. So nowadays, this artificial intelligence, specifically this machine learning, deep learning, these are going to be a buzzword everywhere, even in industry as well as in academic research. You will find the application of these machine learning, deep learning. People are trying to attempt to solve every problem through these techniques. So first, we will try to understand what is the basic ethos of as a faculty. Most probably, many faculty members may be aware what is all these things, but we would like to discuss from different perspective what all these are. Okay, so this is the outline of my presentation. Importance of learning, traditional programming versus machine learning, classical definitions, some classical definitions of machine learning, some popular examples around us of machine learning, classification of machine learning models, and we will try to cover at least one algorithm, either decision tree algorithm or name based algorithm. And these machine learning models, these models can be built with using any of the machine learning algorithm. So our objective is to cover any one, or if time will permit, then we'll try to cover both the models, machine decision tree as well as naive Bayes classifier, and evaluation of this classification model. Once we have prepared the model, then how to evaluate the model, what are the different parameters of evaluation. Okay, so first we'll start with the why we learn actually. What is the basic objective of learning? So there are some tasks where like there is no need to learn to calculate the payroll, but there are some tasks where we use learning means how to incorporate, imbibe the past experience of solving anything in to solve the future problem. So how we can gain the experience to solve the future problem? So learning is basically a process by which a system improves performance from the experience, or especially the past experience. Learning can be used when a human expertise does not exist, like suppose we are navigating on some unknown surface, navigating on Mars, where we don't know what is. So we can use this learning, we can use our experience of other things to explore the unknown. Humans are unable to explain their expertise, like speech recognition, what are the inherent, why we are able to do so, or solution changes in time, means if our whatever solution we have find, the solution will be changed over the period of time, then learning is required, and solution needs to be adopted in particular environment. So these are the different instances where we can apply the learning. So learning means learning general models from the data of particular example, or we will gain experience of one problem or one particular case, and we will try to apply, or we will try to generalize our experience to solve the many other problems. So why nowadays this machine learning is important, or this learning or machine learning is specifically important? Because machine learning is a very old technique. The first time machine learning was coined, this term was coined in around 1959. But we are saying that for machine learning we need experience comes from the data. So nowadays data is cheap and abundant, means available in sufficient, or in form of data warehouses, data mart. But knowledge or extraction of knowledge from these available of huge amount of data is expensive and scarce. So for example, in retail, customer transactions to consumer behavior, like people who bought Da Vinci Code also bought, means this is one inference. If one, if customers are buying this, then they will also bought this. So experience can be gained through the available of data, and nowadays data is available, data is cheap as well as available in sufficient amount, but extraction of knowledge is still challengeable. So building a model that is good and useful approximation to the data. In traditional program, traditional program we write set of instructions which is known as program and provide some data, and we'll calculate output based on this data. Suppose we want to calculate the sum, then we'll write instruction 3 4 line code and give some data. But in machine learning, we will data is there. Data is the most important part of uh, any learning. Either it is machine learning or deep learning. In case of deep learning, more data is required. So data as well as output. Output is what means what we want from this data. What is our desirable output, and this machine learning model will give a set of rules how to extract. So this is the fundamental difference between traditional programs and machine learning programs. In traditional program, we get the output, but in machine learning program, we get the rules, or we can say we get the program. The difference between ML and traditional program in input. In traditional program, we use letters, numbers, symbols, limited type of communication media like keyboard, mouse, this in form of, if you want to give the input in form of files, etc. But in machine learning programs, the input can be anything what we can perceive through our senses, uh, sense organ. It's like input can be a sight, one, two, or three-dimensional objects, sound, spoken language, music, noise made by the objects, touch, temperature, smoothness, resistance to pressure, etc. Smell, every kind of odor, taste, sweet, sour. How these inputs will be converted? So there are different sensors, transducers are available, which can easily convert the sight, sound, touch, smell, different types of senses into digital form. So we can process these inputs in ML program. Processing in traditional program, we manipulate and store symbols using set of previously defined instruction. But in machine learning programs, engage in pattern matching and problem solving, where information about uh, the world presented to the ML program in digital format. And this ML program can self-learn, potentially including developing its own new algorithm to achieve the objective for which the program was created. What it means? It means in ML-based program, the learning is involved, means the whatever algorithm we are using, this algorithm will itself find the underlying pattern, or the inherent pattern exists within the data, and on the basis of these inherent patterns, and we can say in terminology the features, it will learn the task. In traditional program, the output may be limited to alphabetic or alphanumerical, communicated to computer screen, paper, or magnetic disk. But in ML programs, in addition to the whatever output we get in traditional program, it can be synthesized speech, visual representation, manipulation of physical objects, or movement in space. Like we can incorporate these ML programs or ML model in robots, or means there are the other things which can be incorporated in output of. So this is the fundamental difference between a normal programming and machine learning. But the important thing is the data, how to process data and algorithms, how to process this data, and definitely different algorithms are available. We'll see. So first we'll see what is this machine learning. So classically there are different definitions are available of this machine learning, but in literature few definitions are popular. Like this machine learning is the science and art of programming computers so that they can learn from the data. Machine learning is the field. This machine learning, as I said, machine learning was first coined by author Samuel in a conference paper in 1959. And author Samuel defined machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. More, this Tom Michel a popular book of writer of the author of popular book of machine learning. He defined machine learning task as a triplet of P, T, and E, where this a computer program is said to be learned from the experience E with respect to some task T and some performance measure P. If its performance on task T is measured by P improves with experience. So machine learning is defined as P, T, and E. One more definition, ML is a subset of larger field of artificial intelligence that focuses on teaching computers how to learn without the program for specific tasks. Actually, artificial intelligence is an umbrella and machine learning is a one part. Artificial intelligence cover different things. Out of learning is a one aspect, and this learning part is covered by either machine learning or deep learning. These are some popular example, or we can say every day we use these examples uh, of machine learning application. First, every day we'll check the mail and the filtering of messages, and many other AI-based facilities are incorporated in almost all email service provider. So first is this spam and ham messages, means when whether incoming message is spam or ham. If it is spam, then send to the spam folder, or it will be delivered to our inbox. The the recommendation engines used by the song services, Spotify, the movie Netflix, and the other Amazon, Flipkart, and many e-commerce platforms are using this recommendation extensively, using this recommendation engines to recommend their products. And we are using uh, either anyone. If you are a song lover, then probably if you are movie lover, or you are shopping, or for any purpose, we are using all these things. Just suppose we are visiting the Amazon website, so millions of products are there. It is very difficult to exhaustively search all these products, all these catalogs. So what they will suggest on the basis of our preferences, our age, our location, or our past purchasing behavior, the range of product, or even on the base of our searching, they will recommend the product. Similarly for songs, similarly for movie. So this is also one of the most popular application of machine learning techniques, which are known as uh, recommendation engines. The self-driving cars uh, being developed by the Tesla, Google, and many other companies. Now these self-driving cars are even in some cities, USA, Europe, they on road, and as a pilot project, they are used by the people. Facial recognition in photo services in Facebook, Google, these are also popular application. Automatically, they will detect uh, the face and tag, automatic suggest the automatic tagging. This Google's DeepMind AlphaGo computer. This AlphaGo is Go is a game, and this AlphaGo became the world champion of this Go game. So in game playing, personal assistant like this Alexa, Siri, Google Assistant, Win Predictor. So many more applications around us. Every day we see, we feel, visit these ML applications. So why we are using machine learning algorithms? Because problems for which the existing solutions required lot of hand tuning or long list of rules. The same tasks can be done by the ML algorithms by very simplified way and with higher accuracy. The complex problems for which there is no good solution at all using the traditional approach, ML can find a solution. Or the fluctuating environments, it is very difficult to learn the fast changing. So ML system can adapt to the new data quickly and getting insights about the and complex problem with large amount of data. So first, these are the some instances where we can use these machine learning techniques. For example, just suppose we have taken a simple example of sending email to spam folder and deliver. So if this task will be done manually, then it will be time consuming, as well as the accuracy will be low, because every time we have to write the rules, and then if something will be changed, then again we have to rewrite the rule. So such type of tasks is difficult through hand tuning. So it can be automatically, it can be performed using the ML algorithms. So this is the way how to solve the problem. In both the way, either it is traditional way of solving the problem or machine learning way. So first we have to study the problem, or we have to learn about the domain, what we are doing. Suppose we want to diagnosis the disease, then we must aware about the what are the symptoms, and which feature will denote the which disease, like this. So first we have to study the problem, write the rules. Suppose we are doctors are reading the x-rays, then doctor must be aware about that this spot will indicate this disease, or this spot will indicate this sign. And then we will write similarly, like if we'll found the dia of circle more than this, then this will be the disease. So we have to write the rules, evaluate. If there is error, again we will analyze, and iteratively we will perform this process. Similarly, in case of machine learning, what we'll do, we will study the problem and collect thousands of millions of x-rays, and with the help of these x-rays are treated as a data, and with the help of this data we will train the models, and we'll fine tune models, evaluate the solution. If model is working proper, then it's okay, otherwise we will calculate the error. There is a standard way of doing this task. So and again send. So after some time, if our model is tuned, we can test this model for new x-ray images, or for instance for new data. So this is the way how these traditional programming models and machine learning models will work. So here the difference, rather than writing the rule, we are using the data. Now the accuracy of solution, or the exactness of the model, will depend on the quality of data. Quality of data, these two parameters, quality of data as well as which learning algorithm we are using. So this is an example, simple example for suppose, for example, we want to design a simple spam filter. So spam means we are aware that which type of messages are generally, just suppose if message contain either the body of the email or the subject of the email, like for you, credit card, free, friendship, gift, lottery. We have identified certain number of some terms, and we know, we have decided this: if any of the email will consist any of the term, then this email will be treated as a spam email. We will not entertain, we will not read such type of mail. Okay, so you'd in this way you will notice some patterns, and you will write a rule or detection algorithm for each of the patterns that you notice, and your program will flag email as a spam if number of these terms are these terms are detected within the mail. But if after some time, spammer will notice that his or her mails are not delivered, because someone will detect just because of this term. Suppose this for you. So if our email will contain this for you, so are blocked, so they might start writing for you instead. Okay, what it means the spammer will also adopt and accordingly change their strategy. So again we have to rewrite the rules. But Again, we have to rewrite the rules, but in machine learning, automatically it will learn. This process can be automated. It will see the patterns of there are different algorithms are there. It will see the pattern within the email, and automatically, rather than writing frequently this for frequent changes, rather than writing the rule, it will automatically find that this for you is replaced by for you, and will also block the message. So in this way, we will. I thought this is the simplest example to understand how this machine learning algorithm will work. Now, the reason for this growth of machine learning is their application. There are two facets, or we can say that two types of reasons are there. First is its application in speech recognition, language, natural language processing, NLP, computer vision, medical outcome analysis, robot control, computational biology, or many other applications. Almost every field we can find the application of this with some less or high accuracy. You can find application in every field. And second is the second reason of popularity or growth of this machine learning is the improved machine learning algorithm. Nowadays, every you will find this Kaggle and many competition platforms are there. These where the ML based competitions are there. And every day we will find the different algorithms which are more competitive as compared to previous ones. And improving as data is essential for machine learning algorithm to learn the algorithm. So improve the data capture, networking, and fast processing. If we'll gather the large amount of data, how we'll process. So now these GPUs, TPUs, and different types of processing platforms are available. Softwares too complex to write by hand, so we can use these machine learning models. New sensor input output new sensors input output devices to capture the different types of inputs and convert them into uh, a digital form. So demand for self customization to user environment. So these are the reasons of for popularity of machine learning uh, field. Now we move to some specific thing. This is the general introduction of what is this machine learning, and broadly how we can do. Now we come to the point that what are the different machine learning models, or how we can classify the different machine learning models. So machine learning models are classified on the basis of, there are different ways to classify the these models. So first way of classifying is the what data is available. Okay. For example, we are saying that for working of any machine learning algorithm, data is must. So how this data is available, or and how this data is presented to the uh, our algorithm. So on the basis of the available of data, these machine learning algorithms are classified into supervised, unsupervised, reinforcement learning, semi-supervised learning, active learning, transfer learning, etc. How we are getting the data? So whether online or offline, what are the different types of model, whether it is a generative model or whether it is a discriminative model, whether it is a parametric or non-parametric, whether it is a probabilistic, whether it is a non-probabilistic, like this. Still, these criteria are not exclusive. We can combine them in any way we want. So first, popularly we are using the supervised and unsupervised algorithms, but now the supervised and unsupervised machine learning algorithms are saturated, almost saturated. And the new type of algorithm, or the new algorithms which are gaining popularity, or which are popular right now, is reinforcement learning and semi-supervised learning. Most of the research is going on in semi-supervised learning or reinforcement learning. So first we'll see, for example, how we are getting the data, whether this is online or offline. Online, offline means in machine learning algorithm data. Just suppose we are presenting, we want to use the
Certain crops రెండు కలిపి ఇచ్చేసాను.
we want to use the 100 samples. So how to these 100 samples will be used? Whether we present one sample, one instance to the algorithm and algorithm will process it, or we present 10 samples at a time and algorithm will. So in offline learning, in in online learning, one sample is presented at a time and algorithm will process it. In offline learning, this offline learning is nothing but the batch learning. Okay, so the data samples are presented in form of batches. So it may be batch means group of samples will be presented at a time. So generally suppose thousands. So 1,000 data presented at the one time, or we can present 500. So it can be divided into mini batch learning is most practical. So in this way. So first we will discuss what is this supervised learning. In supervised learning, the data is available as well as the label is available. For example, here this is the example of supervised learning. So here training data is available as well as the labels. Our target is also available. For example, just suppose we want to design this spam classification model. So we have 10 millions. You may be heard about the Enron dataset, Enron email dataset. So we have 1 million emails as well as their labels. Which email is spam and which email is ham? Okay, so this such type of where data as well as label is available, such type of learning is known as supervised learning, where both input data as well as target is available. So this supervised learning is used for prediction, classification, regression. Means classification and regression are two examples of supervised learning. If our labels are discrete, just suppose we have 100 emails and their label is also. Just suppose this mail is a spam, this mail is a ham. For 100 emails, we have labels for all the email. Then these are means this is the example of supervised learning. Okay, if the labels are available in discrete, just suppose class is available, whether test is positive or negative. So there are two classes, positive or negative. Then or we can say even 3 classes, 4 classes. If means discrete labels are discrete labels, then we'll say this problem is a classification problem. Otherwise, if labels are continuous or real values, for example, we want to predict the stock prediction, house price prediction, for such type of application where the outcome, the labels are real values. So such type of problem is known as, both are supervised, but with discrete label it is known as classification. With continuous with these real values, it is known as regression. So what is the way of working of supervised? In supervised learning, we will collect the data like this training text, documents, images, sound. It will depend what is our problem. Just suppose we want to design a email classifier, then obviously we'll use the email dataset. If we want a document classification, if we want image classification, then we will extract the features, attributes. Obviously records will be, just suppose email, so we will extract the features from email. What can be the feature of email? Like this words for you, lottery, or this can be the attributes, or this can be the features. So there are two terms are interchangeably used. One is attribute, another is feature. Just suppose we want to keep the record of students, we want to predict which student will be placed or not placed. So obviously we must have some data about the student, and what just suppose 10 students are there, so we will keep record of this 10 student on different parameters, like what was the percentage of this student in 10th, in 12th, in from first to eighth semester, or he was appeared in he or she was appeared in some competitive coding competitions, what was the score, or in this way means we can enrich this data set for predicting the outcome, whether this student will be placed or not placed. So whatever we are writing, so these are known as attributes. These are known as attributes, and these attributes we can derive the numerical value from these attributes, and these numerical values are known as features. So we will extract ultimately feature vector. So there is a difference between attribute, and a small little difference between attribute and features. Like just suppose salary can be a one attribute of employer, employee, and this salary, what the mean, max, median, these can be the features from derived from this attribute. So in this way we will extract the feature vector. Ultimately this feature vector will be passed to any machine learning model. So now your model will be trained, and these labels will also pass. Just suppose for email 1, whether this email was spam or ham, so this label will also be passed. And after training, completion of this training, now your model will be ready for testing. We will present the unknown data, unknown email. We will extract some feature from this email, and this feature vector will be passed, and it will be classified whether the new email is a spam or ham. This is the example of classification. Similarly, for house prediction, for a stock prediction, we can do the regression. So this is the example of how supervised learning algorithm will work. In case of unsupervised learning, the only one thing here, the target data is available. Here target data is missing. Only input data is available. So same problem here, labels are not passed to the algorithm. We will pass the data, again we will extract the feature, and this feature vector will be passed. This unsupervised learning algorithm can be of the different tasks can be done, like it can be clustering, it can be for association rule mining, or it can be for dimension reduction, or the different way of doing this unsupervised learning algorithm is there. So here only input data is there. We will extract the feature vector and pass to the now algorithm. This unsupervised algorithm will automatically find the pattern within the data, and it will just say, suppose the more simplified example, this newborn babies, after when the child started to going to school, so they will learn that this alphabet is known as A, this is known as B, this is known as C. So teacher is there, teacher is trained them, they will try to write A, then again teacher will correct, no, this is not the way of writing the A, your A, they are doing writing A, but their A is not correct. So the target is there, their teacher will write this is the correct A, you try to write this. So here the target is available, the target what A should look like, it is available. But these infant babies, they automatically perceive their environment, and after some time they will detect patterns automatically. They will, after some time, they will start to recognize this is the milk bottle, or means whatever be their interest, they automatically, without giving any explicit input, they started learning. So this unsupervised learning is like that. Automatically it will extract the feature, and how it will extract, the different techniques are there, and because the mathematics is involved, they automatically learn, and it will categorize, like this is our training data automatically. Suppose the fruit classification, with different types of mixture of fruits are given. It's a banana. Banana is a different shape size. So, but like tomato, apple, and such type of similar kind of fruits are there. Mangoes. So, how we can automatically algorithm will decide the parameter like first shape, color, size. Okay. So, if apple their shape is different, but almost apple shape, so other fruit can be of same size, but their color may be different. If their color and shape both are same, then their weight may be different, like this. So in this way automatically these are the inherent patterns extracted from the objects, and on the basis of this it will semi-supervised learning. As I said, this supervised and unsupervised learning, the most of the research is going in this semi-supervised. In semi-supervised learning, what is the problem with this supervised learning? The cost of labeling is very high. It is very easy, but it is very easy to say that labels are available. But just suppose millions of yeah, hundreds of thousands of X-ray images are there. So who will label whether this X-ray is representing this disease, this X-ray is indicating this disease, this X-ray is not indicating? Experts are required, expert doctors. So cost of labeling is time consuming as well as very high. So because experts are required. So in semi-supervised learning, what we'll do, in semi-supervised, some partial labels are available. Means some instances are labeled, and with the help of these partial labels, we can learn the labels of remaining instances. So that's why this just because of to avoid the cost of labeling, this semi-supervised learning is, because nowadays lots of data, how much data is we are collecting every day. Suppose if shopping mall wants to deploy some algorithm, then thousands of customers are visiting every day and they are purchasing the thousands of products. So it is very difficult to label all this. So abundant data is available, and exhaustively label all these data is very difficult. That's why we can move ahead with the help of this semi-supervised learning. So these are some example of semi-supervised learning where with the help of partial label, means out of 100, if we have 2 labels, 3 label or 10 label, then also we can, with the help of this 10, we can do 20, with the help of this 20, we can do 30, 50, and in this way we can label, although accuracy is also concerned. Another important class is reinforcement learning. So the learning system in reinforcement learning, the learning system is called agent, and this agent will learn on the basis of this reward and penalty. Means in reinforcement learning, it will learn with the help of environment only, and whether it will get reward or penalty. Just suppose in game playing, in two players game, we will move something, our opponent will move, then we have to learn that what will be the possible move of if we'll move this. So in this way, our robot navigation, robot will start navigating. If will found obstacle, it will get penalty, and it will correct the agent will correct its path. So in reinforcement learning, on the basis of the environment feedback, uh, the agent will learn, and the application of reinforcement learning, especially in game playing, robot navigation, and these we can say this the driverless cars, these are also example of reinforcement learning, where they will learn from the environment and according to act accordingly. So the next is transfer learning. In transfer learning, if we have knowledge of one domain, we can transfer this knowledge uh, to other domain. So in some domain, like label data are in short supply, calibration efforts is very expensive, and learning process is time consuming. For example, just suppose the problem is we want to uh, design a system of cancer detection. So different 100 types of cancers, 100 types of cancer, and some cancers are rare, very rare. So it is very difficult that the previous uh, examples may not be there, or label data may not be available, but we want to train the system. So what we can do, we can take, if label data is available of other form of cancer, then we can take help of that knowledge to detect this rare form of cancer. Means what we are doing, we are transferring the knowledge of one domain to another, although here the domain is similar. So this transfer learning is of two types: homogeneous transfer learning and heterogeneous transfer learning. For example, if we want to learn the driving, and if we have previous knowledge of driving, just suppose we want to learn car driving, and we don't have even experience of bike riding, or even if we have experience of tractor riding, then this skill, the right, although the driving a tractor is a different than driving a car, but we can transfer the knowledge of learning of driving the tractor into learning of driving a car. So here it can, this transfer learning can be done either it is homogeneous transfer learning. If the input feature space between the source and the target data is same, then this is known as homogeneous. Means how many number of feature space. Feature space means suppose for other type of cancers we are using 100 features, so similar 100 features are used here. Then homogeneous. Heterogeneous transfer, if the input feature space is different of the source and target data, then this is known as heterogeneous. So this is also one type of learning where we can domain adaptation, we can transfer the knowledge of one domain to another domain. So you can see here the how this learning is different from the our traditional machine learning. Active learning, the learning algorithm can choose its own training example or ask teacher for an answer on selected input. So these are the different types of learning, and this is the summarized view of machine learning algorithms. So this classical learning can be divided into supervised, unsupervised. Supervised further can be divided into classification, regression, and some instances are there. Clustering, unsupervised can be further divided into clustering, pattern recognition, ensemble learning, reinforcement learning, this neural network based learning, this neural simple neural network, this perceptron, multi-layer perceptron, etc., and this deep neural network. So this is the we can say the summarized way of how these different types of learning algorithm. And here you can see the more algorithm, like in machine learning algorithm there is a supervised, in supervised there may be classification and regression. In classification, decision tree may be a one algorithm or one class of family of algorithm. Further, this decision tree can be of any of the type classes, this card decision tree, ID3, C4.5, C5.0, this chi-squared automatic interaction detection, decision instant condition. So in this way, you can imagine the landscape of the machine learning, how varieties are there. So now we will move to our, this is the general introduction of what are the different types of machine learning algorithms, ranging from, yeah, one, I think I miss one, two, three things. When we are discussing the classification of machine learning models, so one basis of classification was the availability of the data. And on the availability of the data, we have classified these machine learning algorithms in supervised, unsupervised, reinforcement, semi-supervised, active learning. And how these are getting online or offline, I have explained online, offline. There are some models which are known as discriminative model and generative model. Discriminative model means how the working of the model. Just suppose, for example, there is a one machine learning algorithm, support vector machine. So this support vector machine is draw a decision boundary to classify the input space by drawing a hyperplane. So it will discriminate. So this samples will belongs to one class, and this sample will belongs to the other class. So if algorithm is drawing using the hyperplane to discriminate between the uh, different classes, then such type of algorithms are known as the discriminative. Generative, just suppose for example this naive Bayes classifier, they will generate all possibilities. Suppose we are using two classes, so it will generate probability of both the class. If you are using three classes, then it will generate probability of all these three classes, and the highest probability class, the highest probability will be chosen as this is the class. So in this way, discriminative model or generative model means how these models are working, whether they are drawing the hyperplane to discriminate between the samples, whether this sample will belong, this side of samples will belong. This hyperplane can be a point, can be a line, can be a two-dimensional, can be a three-dimensional, or it can be a multi-dimensional. It will depend on the complexity of the problem. So this is the one way of their classification, whether we are using discriminative or generative model to generate all possibility. The another was the parametric and non-parametric. So if the algorithm will use some parameters, then these models will known as parametric model. For example, this perceptron network, or we can say logistic regression. These are the example of parametric learning or parametric model. Why parametric? Because here we are learning the parametric, like in sorry, like in yeah in perceptron, what we are learning, actually we are learning the value of w and b, weight vector and bias. So parametric means the performance of learning will not depend on the number of samples. It will learn the value of w and b, and it will not affected by the number of samples. So such type of models are known as parametric model. For example, as I've given this perceptron network as well as this logistic regression. Similarly, non-parametric, yeah, someone has raised hand. Yeah, please. If you want to ask question, please. Suresh Kumar. Hello. Hello. Yeah, I'm audible or not? Hello.
Yes, sir, you are audible.
Yeah, someone has raised the hand to ask. So if you would like to ask, then you can ask. Hello. Okay. So example of non-parametric is KNN algorithm, where we have to store all the training samples for learning. Then this is the example of non-parametric. So this is the difference between parametric and non-parametric model. Other examples of non-parametric is the decision tree. Again, it is tricky actually. If we allow to grow the decision tree to the full, then this is the example of non-parametric. Otherwise, if we restrict the growth of decision tree, then sorry. then it will be converted into parametric. If we'll restrict the now, what is this supervised learning frameworks? This supervised is now we will focus on the supervised. As I explained, what are the different types, how we can classify these algorithms, what are the different types of machine learning models. So, this supervised learning is basically y equal to fx, where this x is the feature input feature set, and this f is our prediction function. Means for every model whatever we are using, we will use some mathematical function. This mathematical function will learn whether this function can be our simple linear function, it can be a non-linear function, it can be rbf, it can be a tangent function, or any other mathematical function. And on the basis of, we will pass this inputs to our algorithm. This algorithm will learning means some mathematical function will learn, and it will predict. This mathematical function will give, just suppose we are passing this f is a square function. So if x is 2, then the output will be 4, like this. So you can imagine the curve, what will be the curve of this function. So for training in supervised learning, we'll given a training set of labeled example x1, y1, x2, y2 up to xn, yn, where xi's are input and yi's are output. And we estimate the prediction function f by minimize the prediction error. Because in supervised learning, the target values are available. So we are getting the predicted value and we will find the difference between target and predicted. And on the basis of this error, we will improve the model. So applying f to never before seen test example, or we, in other words, we can say the test set, and to output the predicted. So we will calculate the difference between. Here you can see this diagram is more self-explanatory. Here we will this is our data we have collected. This data can be anything. It can be images. It can be a sound of different sound, or anything else. Set of emails or documents. We will extract some features. This X and these features will be passed along with the labels, because here we are talking about the supervised learning algorithm. So model will be created. What is the difference between algorithm and model? When algorithm will be trained with some data, so this model will be prepared. Now this fx is ready. So algorithm with training data is known as model. So sometimes we use machine learning algorithm, sometimes we use machine learning model. So when algorithm is trained with some training data, then it will be converted into model. Now this model will be tested against the unknown data, and some prediction, we will receive some prediction. So here our objective is to get this fx. When we'll get the fx, this fx is nothing but our trained model, and we will pass. So suppose here is some example. We are using two features, size and color of any cloth like AML, their color, and these are their prices. So with the help of this model, we will predict price, and we will calculate the difference between y, which is the actual, and fx, which is the predicted. So difference between y and fx is known as loss or error, and our objective, or the objective of any algorithm, is to reduce or to minimize this error, or to optimize this loss function. The standard supervised machine learning process is, first we have to extract the feature values like x1, x2, x3, x4, xn, up to n features can be extracted from any instance. This feature, obviously, this is known as the feature vector, and this is our label. So this will be data set. From data set we will extract, we will create these input variables, and because this is the supervised, so input as well as target. So we'll perform different data cleaning, data curation, remove redundant features. We will perform certain exploratory data analysis. We apply PCA, SOM, LDA. Different techniques are available, and this pre-process data set is used. So this pre-process data set, we will split it into splitting means training and testing. So generally different training, this k-fold training, where some 80%, 70, 30, 80, 20, some percentage of data, like 80% data is used for training and remaining 20% is used for testing. We will use some algorithm like learning algorithms. It can be SVM, decision tree, GBM, or whatever we have seen earlier. Any algorithm can be used here, and we can, if further we want, then we can apply the feature selection. Just suppose we can tune the hyperparameters, and in this way, some algorithms, there are two terminology again: parameters and hyperparameters. Parameters are the essential of any algorithm, but hyperparameters, these are not mandatory, but these parameters are very useful in performance boosting of any algorithm. So generally we not only divide this training and testing, but we use the three set: training, validation, and testing. So validation set is just used to optimize the hyperparameters, and means for what value of these parameters this model will perform the best. And then the cross validation, will use this cross validation and measure the performance. Like if we are using the classification, then different performance measures: accuracy, sensitivity, specificity, MCC, Matthew correlation coefficient, and ROC, AUC. But there are different parameters are there. If we are using regression, then R square, MSE, RMSE, these parameters are used. So this is the standard way of doing performing the supervised machine learning process. So this block diagram is the summary of how we'll do, how start from the initial data, how convert this data set into feature vector by performing the initial pre-processing, data cleaning, data curation, removing the redundant features, the splitting, training data, use algorithm, and different models. One more reason, or we can say the actual reason of popularity of machine learning algorithm, is the availability of tools. We don't hundreds of, we have seen earlier that even decision tree family algorithms, you can find 10, 20 types of decision tree algorithms. For clustering, for any sort of algorithm, you can find many, and it is not required to explicitly program each and every algorithm. So the packages are available, and most of the packages are free. Just suppose popularly nowadays we are using scikit-learn, R, or earlier this Weka was very popular. This is GUI based. We don't even not required to line a single line of code. We just graphically use all this, and most of the are free. So these availability of these libraries for any type of, for statistical, mathematical, general purpose machine learning, narrow solutions, like we want to use these XGBoost, LightBoost, KateBoost, XGBoost. So this for this family, or this leave SVM for SVM only. So for natural language processing, this NTLK, GenSim. So such type of libraries are available. Different libraries are available. We can use this library. So this is also the one of the reason for popularity behind the machine learning tools and techniques. So it is very easy as well as handy to use these techniques. So this is all about introduction of machine learning. If if participants ask some question, then you can ask, so we can move ahead. Any general question regarding this machine learning? Hello. Anybody?
Suresh Kumar has raised his hand. So, Suresh Kumar, if you want to ask any question, then you can ask. Mr. Suresh Kumar, if you want to ask any question, you have raised your hand. Please go ahead.
Yeah, anybody, because it is going to be monotonous actually. I am not whether many, I can see the many partitions, participants, more than 70 participants are there. So if you have any question, just because of your curiosity, these are the basic thing. If you, I will try to answer. Okay. It seems that no question. So, as I said, I have introduced what is machine learning, what are the classification, different classification of machine learning models, whether it is supervised, unsupervised, reinforcement, active, online, offline, what are the different types of model, whether it is parametric, non-parametric, generative, discriminative, probabilistic, non-probabilistic. So, and how the supervised learning algorithm will work, what is the standard procedure actually. We have to extract features, what is the difference between feature and attribute. The attribute can lead to, we can derive the multiple feature from the same attribute. As I have given one example, like the salary, age, we can derive multiple feature values from the same attribute. And then this feature vector can be used for training, and we can train. So the algorithm can be converted now. Model, the trained algorithms are known as model. This model is nothing but a representation of mathematical function. And with the help of this mathematical function, we can perform the prediction, we can perform the classification. So again, the supervised learning algorithm can lead to the classification problem, or it can be lead to the prediction. If our labels are discrete, then classification. If labels are continuous real values, then it is regression. Again, the regression can be of any type. Classification can be of different type. Different algorithms are there. So out of this, all these, we will try to cover one algorithm, which is popularly the decision tree. This decision tree is not a single algorithm. This decision tree is a family of algorithms. As we have seen in previous slide, how many algorithms. So decision tree algorithms still keep their popularity nowadays in data science, machine learning, because they can produce the transparent decisions. So still, some will rush behind few algorithms. Only every algorithm has universally there is no algorithm which is superior than other. It will again always, it is context dependent, in which context we are using. Sometimes this decision tree may produce the better result than the random forest, or naive Bayes may produce the better result than the random forest, or some other boosting algorithm. So it will depend on the context, in which context, for which problem we are using which algorithm. So every algorithm is important. Still means in industry, every algorithm is used. Naive Bayes is still used. Decision tree is also used. Yeah, although some more powerful algorithms are there, like this XGBoost library or some boosting based library, but it is not just because of these are available. The previous algorithm has no, universally no algorithm is best. So an algorithm is transparent only if a decision can be read and understood by people clearly. Nowadays, the deep learning is superstar of machine learning. Nowadays, it is an opaque algorithm. Means whatever we may get the better result, but the reasoning why we are getting this result is very difficult from this deep learning algorithm. So where we need this explanation, so still these decision tree algorithms are popular. So this ID3 iterative dichotomizer, which was the successor of the D3, is the most common conventional decision tree algorithm, but it has bottleneck. attribute must be nominal values, data set must not include missing data. So yeah, it is not necessary that all the time attributes must be nominal. It may be some categorical values, it may be some numerical values, and data must not include missing data means if for any real time data, it is not possible that missing values there. If we are keeping the record of a student, sometimes if some age will be missing for a student or some marks will be missing, it doesn't mean that your our whole solution will be failed. So in practical problem it is very difficult. So for this algorithm finally fall to the overfitting. So this Rose Quinlan, inventor of ID3, made some improvement over these bottlenecks and created new algorithm. This is known as C4.5. We'll see what is the difference between all these decision tree algorithm. There is a small difference, otherwise basic function. The C4.5 algorithm is implemented in Veka as a J48. You will not find C4.5 in Veka because the C4.5 some copyright issue. So they use in Veka as a J48. So J40 is nothing but a C4.5 basically. Mm. Another this card classification regression tree, CHAID, chi-squared automatic interaction detection, perform multi-level splits when computing classification. This Mars. So these are the variants of different variants of decision tree algorithm or this decision tree family. Like we have seen the decision stems. Decision stems are used as a weak learner, where single level trees basically. So they are not independently used, but they use um, in like in ensemble learning, and suppose in random forest or in other ensemble models, these decision systems are used. So these are these M5 we have seen earlier. So these are the some decision tree algorithms. So there is a small difference between there. We'll see. So first, what is this decision tree algorithms? Quickly, I will try to complete it. So basic algorithm is basically a greedy algorithm, and you as a computer people, you know what is the meaning of greedy. So tree is constructed in top-down recursive divide and conquer manner, and at the start all training examples are at the root. Attributes are categorically continuous value, they are discretized in advance. Basically this is the description of ID3 algorithm. That's why uh, examples are partitioned recursively based on the selected attributes, and test attributes are selected on basis of heuristics or statistical measures, like this information gain, the entropy, information gain ratio. We'll see what is this, and we will stop this formation of tree or this partitioning. All samples for a given node belongs to the same class, then there is no possibility of further splitting. There are no remaining attributes for further partitioning. Yes, and there is no samples are. So these are the different conditions of stopping. Some basic terminologies of tree, how this tree. So root node means represent the entire population of sample, further divided into two or more homogeneous set. Splitting process of dividing the node into two or more subnodes. Decision node, when subnode splits into further subnodes, then it is called the decision node. Leaf or terminal node do not split, is called the leaf or terminal node. Pruning, process of removing the subnode from decision tree, opposite to the process of splitting. And branch or subtree, a subsection of the entire tree, this is called the branch or subtree. A parent or child node, a node divided into subnode, is called the parent node, and subnode, whereas subnodes are the child of parent node. So these are the some basic terminology used in the decision tree, but this is not important. This terminology these terminologies are obvious. The types of decision tree: categorical variable decision tree means categorical target variable. For example, predicting the relative price of computer as one of three category: low, medium, high. Features could include monitor type, speaker quality, RAM, SSD, etc. Continuous variable decision tree is continuous target variable. For example, predicting the price of house. Feature could include the size, type, locality of the house, and in this way, price will the different. So these are the basic two broad categories of decision trees: categorical and continuous variable decision tree. What is our objective? This is suppose we have consider this small data set with 14 instances only. and this data set will be converted into this decision tree. Means when we'll apply one algorithm, then this data will be converted into. So here what we can deduct from this decision tree, we can form the rule. This decision tree can lead to different rules, set of rules. So that's why this decision tree is preferred. Yeah, although this data set is a small data set, only 14 instances are there. If in place of 14, if 14,000 instances will be there, then you can imagine the complexity of this decision tree. Yeah, so or even millions of instances are there. Means this data set will consist 10 lakh samples. Then you can imagine the size of this decision tree. Okay, but still the way, for simplicity, we will consider this example only. So this is our objective, means how this data will be categorized into decision tree. So first question is, why we selected, why this student is selected. Here you will say age, income, student, credit rating. Means this is a simple data set, and this data set consists 14 instances, 14 samples only. Manually we can calculate all the calculations. So age is one attribute, income is another, student, so 4 attribute and 1 class by computer. Means if age is youth, income is high, and student no, credit rating is fair, then he will not computer. The decision is whether it will buy computer or not buy computer. It's a simple. So here we can say student no, income high, age less than 30, then buy computer will be no, in this way. So suppose why we selected this student as a root node, because initially all the attributes are available, means age, income, student, credit rating. So first question is how to select the node, splitting node. So first, obviously, first split will be performed on root node. So how we'll select, and for that we use the information theory. We will calculate the entropy, which is the measure of uncertainty associated with each and every attribute of the data set. For example, here 4 attributes are there. So we'll compute the entropy of all these 4 attributes, and the maximum entropy attribute will be considered as a splitting node. So out of this age, income, student, credit rating, the student has the maximum entropy. Now we'll go, what is this entropy? So entropy is used as a selection measure of splitting node. So entropy is measure of disorder, or measure of purity, or measure of uncertainty. For homogeneous set of example where all belongs to same class, the entropy will be 0, because there is no uncertainty associated. For example, where half of the example belongs to one class and remaining half belongs to other class, or data equally divided into classes, the entropy will be highest. So if ith possible value of age, probability Shannon entropy formula, this minus I equal to 1 to n pi into log pi. Okay, so there are different types of entropies are there. More than 20 entropies. I have not exhaustively checked the list, but it is more than 20 type of entropies are there. And out of these entropy, why we are considering only Shannon's entropy? Why this mathematical construct we are using? So there is a reason for this also. This is the important thing of this decision tree. So because there are certain with this mathematical construct, why we are using this only, what is the special with this entropy, like why we are using this I equal to 1 to n pi log 2 pi. Okay, where this pi is probability. So there are basic properties. I quickly summarize these basic properties of this uniform distribution have maximum uncertainty. Means the Shannon entropy satisfied the basic properties. This uniform distribution have maximum uncertainty. Uniform distribution have maximum uncertainty means like if we'll toss the fair coin, then this coin can be, if you flip a coin, it can be head or tail. So the probability of getting head and getting tail is equal. So uniform distribution have maximum uncertainty, uncertainty additive for independent events. Just suppose we are one event is we are flipping the coin, other event is means we are flipping the two coin, then their uncertainty will be additive, means whatever probability it will be add to the other. Adding an outcome with zero probability has no effect, means whatever probability will add zero, then there will be no, the measure of uncertainty is continuous in all its arguments. So these are the four basic properties which are satisfied by this Shannon entropy formula. That's why this Shannon entropy formula is used. And this Shannon entropy formula is derived from this uniqueness theorem, Kinchin uniqueness theorem, where the value of this lambda is 1 and it will lead to this. The other essential properties, other additional properties other than the essential properties, the uniform distribution with more outcome have more uncertainty, events have non-negative uncertainty, and events with certain outcome have zero uncertainty. Flipping the argument has no effect. Flipping the argument has no effect means suppose we are P1 and P2. So we can do it as a P2 and P1. So it will not affect. So these are the properties which are satisfied with this Shannon entropy formula. So we use this Shannon entropy formula for computation of entropy. Now this entropy will lead, as we are saying, that different decision tree algorithm like ID3, C4.5, CART. Okay, so what is the difference between these algorithms? The difference is only which measure we are using. So for suppose for ID3 we use the information gain. For C4.5 there is a problem with this information gain. This gain is biased to the unique attribute. So we use the gain ratio which in C4.5, and for CART we use the this Gini index. So only the difference is which measure for selecting the splitting attribute. So select the attribute with the highest information gain in ID3. Let Pi is the probability that an attribute tuple in D belongs to the class Ci, and we'll estimate it by the number of CID divided by the number D. So first we will calculate the expected information, or we can say entropy needed to classify tuple in D. So first we will calculate the info D of the data set by using this formula, and then information needed after using A to split D into V partition. We will partition this data set into V to classify the D, and we will calculate the info AD, means we will calculate the info entropy of each attribute. First we will calculate the entropy of whole data set, like for 14. So for 14 how many years, how many then we will calculate for each attribute, and we will compute by first we'll calculate the entropy for data set for each attribute, and then we'll compute the information gain by info D minus info A. Now we'll see how we'll calculate. Just suppose, for example, this data set, we are considering this data set only with 14 samples. So first we'll calculate the info D. So info D, how many years? 9. There are two classes only, yes and no. So how many yes by computer? 9 instances belong to yes and 5 instances belong to 5. So info D I95. So we will apply the formula here, minus Pi. So probability Pi minus Pi minus pi means 9 by 14 log 2 pi. Summation minus 5 by 14 log 2 5 by 14. So in this way, here we will use this formula, I equal to 1 to n. So here n will be 2 pi log to the base pi. If this n here, because there are two classes only, yes or and no, so that's why we consider the value of n is 2. Okay, so I95, this formula will be, if we'll expand it, so it will be expanded into pi. First pi is 9, so 9 by total 14 minus, yes, minus is there, log pi 9 by 14 minus 5 by 14 log 5 by 14. If 3 classes will be there, then 3. 4 classes will be there, then 4. Like this, it can be this the simple summation formula. You can understand better. It can be expanded. So in this way, we'll calculate the value, and this value will lead to this. So this is what? This is the info D. Info D means this is known as entropy or information of data D. Information of data D. Now we'll calculate the information of attributes. So first we'll calculate the attributes. And what is the first attribute? First attribute is we can calculate in any order. So, but first attribute is, and how many youth, middle, or senior. Youth, middle, or senior. Yeah, basically this sometimes this data set is the age is less than 30 or 30 to 40 and greater than 40 or like this. So it can be converted into youth. Less than 30 is youth, it is middle, and greater than 40 is senior. So the same thing. Somewhere you will find that this age column is written in this way, so it will not affect the result at all. So here there are three things. So age, middle, and senior. Now this youth 2, 3. Here you can see we will compute age, youth 2, 3, I 2, 3, middle age 4, 0, and senior 3, 3, 2. What it means youth, there are how many youths? 5 youths. How many youth? 1, 2, 3, 4, 5. Out of these 5, how many yes and how many no's? So first 2 no, and 3 no, and 2 yes. So that's why we have written here pi 2 and ni 3. So now we'll compute similar way. I equal to 2, 3 means I 2, 3 information 2, 3, I 2, 3, similarly I 4, 0, and I 3, 2 for this attribute age. And now we'll get the info age D. So how will get the info age D? Info age D will be the 5 by 14, 3 plus 2, 5 divided by 14, 4 plus 0, 4 by 14, I 4, 0, 3 plus 2, 5 by 14, I 4. So in this way, we will calculate the entropy or information of attribute age only. And now we'll compute the gain. So gain age will be total info minus info of age, and it will be around 0.246. For this is only for one attribute age. Similarly, we'll compute for income, student, and credit rating. For all attributes, we will compute the gain. The process will remain same like we have computed for youth. The next attribute is income. How many categories are there? High, medium, and low. High, medium, and low. Again, 3 categories there. How many highs are there? 3, 4. So out of these 4, how many 2 yes and 2 no? So this income will be 2 yes, 2 no. So we will calculate I22. It will come around 1. Similarly for medium, how many medium? 6 medium, 4 yes, 2 no. And how many lows? 4 low, 3 yes, 1 no. So we'll calculate, and in this way we'll compute the info of income, and again we'll calculate the gain of income. So similarly, for each attribute we will compute this way, and you will find uh, uh, for credit rating there are two, fair and excellent. So we'll compute info of or we can say the information of credit rating, and ultimately information gain of credit rating. Now we'll check the value, like this credit rating is 0.048. This is 1.1151029, and this is 24. So you will see that out of these four, highest entropy is for information gain is for age. That's why we will select this age as a splitting attribute. So first split will be performed on age, and now this tree will looks like age will split youth. So there are three: age, youth, middle age, and senior. So youth will belong D1, D2, and this middle age all belongs to the same class. So there is no possibility of further splitting. So we will not do anything. This node will be converted into leaf node. The same process, whatever we did with this, the whole data set, we will perform with D1 and perform with D2. And ultimately, this tree will be converted into this. So this is our final decision tree. Similarly, we'll calculate for D1, D2, and up to until unless all instances will belongs to the same class, whether it is no or yes. If there is a combination of yes, no, we will perform again. So this is how we'll construct the decision tree. Important thing is this measure. Which measure? Attribute selection measure. And this attribute selection measure will decide which algorithm we are using, whether we are using ID3. Suppose what we did, this is for the ID3 algorithm. This is not C4.5. If we want to C4.5, then we will use gain ratio, not information gain. Right now we have computed only information gain. Okay, so the summary of attribute selection, this information gain which is used in ID3 algorithm, as we computed in the previous example. Similarly, this gain ratio is nothing but a little bit modifying. The information gain is required, but we will compute the split info also, and this gain ratio gain will be divided by split info. How to compute the split info? By this formula we'll compute the split info. And for cart algorithm, by default in scikit-learn we are using the cart algorithm. So cart will use the Gini index, and this is the formula for Gini index. And one measure is this reduction in variance, or this chi-square, or there are other measures also, the conditional tree. So rather than we are using these splitting measures, we use the significant test. And with the help of, we will not use this in conditional decision tree, we will not use this measures, we will use the significant test. So these different measures will lead to the different trees. Like this information gain will lead to ID3, gain ratio will lead to C4.5, gain index will lead to cart, this reduction in variance will lead to different algorithm, this chi-square will lead to the this shade sort of decision tree algorithm, like this. So now we'll just see example of how to compute this gain. So this value represent the potential information generated by the splitting the training data D, and this D is partitioned into V partitions. And V outcomes of test on attribute A. So how it differs from information gain, which measures the information with respect to the classification that is required based on the same partitioning. So here you can see this information gain measure is biased towards the attributes with large number of values. large number of unique values. So we use this new measure gain ratio. This gain ratio is incorporated in C4.5. That's why this C4.5 is more popular. And how it will use this gain ratio to overcome the problem by normalizing the information gain. So here we calculate the this split. How this is split is, suppose income D. So we can calculate by using this formula. This income is partitioned into 3. This income is partitioned into 3, and number of dj divided by d. So d is 14. Dj means one class, low, high, middle. So 4, 6, 14. So in this way, we'll calculate the split information. For any attribute, we can calculate the split information. And the gain for this will be divided by this split information. It will lead to the gain ratio. So the attribute with maximum gain ratio is selected at the splitting attribute. So the basic objective, or the basic improvement, it will normalize the information gain. So this is about the next measure is the Gini index measure. So in Gini index measure the impurity of D data partitions or set of training tuples as a discrete value attribute having V distinct distinct values occurring in D. To determine the best binary split on A, we examine all the possible subsets that can be formed using known values of A. For example, the income has 3 possible values like low, medium, and high. Okay, so this, as we have seen in the previous case, low, medium, and high. So some 4 instances will be low, 6 will be medium, and 4 will be high. So here we will generate a power set, and this power set will be 2 to the power 3, means 8. And out of these we will discard 2. One is the whole set, low, medium, and high, and the empty set. Conceptually they do not represent a split. Therefore we how many different 2 to the power v minus 2 possible ways to form the 2 partition of the data set. So in this way we calculate the Gini index value, and as we are considering the information gain, highest information gain attribute will be selected as a splitting attribute, and for gain ratio also. But in Gini index we will search for the minimum, the means the lowest value, lowest Gini index value attribute will be selected for splitting attribute. So all attributes assumed to be continuous value may need to other tools like clustering to get the possible split can be modified for categorical attributes. This is the comparison of selection measure information gain bias towards multivalued attributes. Means if we'll include the serial number, then it will it always has the highest information gain, because in ID or serial number every attribute is unique value 1, 2, 3, 4 like this. Gain ratio tends to prefer unbalanced split in which one partition is smaller than the others. Gini index bias to multi-valued attributes and has difficulty when number of classes is large. So these are the comparison of different selection measures. Now we come to the hyperparameters in decision tree. These parameters are not mandatory, but these parameters are used for performance tuning, like criteria used to measure the quality of a split. The default value is Gini in scikit-learn. We want to measure the calculated entropy gain. We can change parameter to entropy. Means when we'll select, we can change the value of this criteria hyperparameter. Otherwise, by default, it will use Gini. The splitter used to choose the split at each node. If we want to subtrees to have the best split, you can set this parameter to best. We can also have the random split for value random set. Maximum depth, integer parameter used to limit the depth of tree. As I've said, if we allow this decision tree to grow full depth, then this decision tree is considered as a non-parametric. But the default value of this parameter is set to none. So that's why you will find that decision tree is considered as a non-parametric. But if we'll set this value maximum depth to some value rather than none, if we set in some value, then this decision tree will be considered as a parametric. So minimum sample split used to define the minimum number of samples required to split an internal node, and maximum leaf node used to grow a tree with max leaf node in the best first fashion. The default value of max leaf node is set to none. So these are the hyperparameters of decision tree algorithm. We can decide, although as I already said, that there is a difference between parameter and hyperparameter. Parameters are mandatory, their values are mandatory, we have to pass their value, then only algorithm will work. But hyperparameters are used only for performance boosting. So this is the difference. These parameters are not, their direct value is not required, but they are important for performance boosting of the algorithm. These hyperparameters may be associated with any of the algorithms. So there are parameters as well as hyperparameters. Now quickly we'll see how to implement this algorithm, this decision tree algorithm in the with example with the same data set. So first this numpy and panda is required. So first we will read this data set, pd read underscore csv, this decision tree data set, whatever we are considering. And we will drop this column, which column? RID, because it is not used. Now we will use the label encoder. These will be labeled. So there is a facility scikit-learn.preprocessing import label encoder. Automatically it will encode. It will depend on the number of classes, how many number of variables are there. It will automatically encode. So in this way, your data will be encoded. Whatever we were earlier using, the text in place of text, it will be substituted by the numerical values. Now your data is ready to feed into algorithm. So we can split, as we are saying that it can be this is our 14 instances, 0 to 13. So now it can be split into training and test set, although it is very small, but still will perform the same process. So we will split into training and testing. So it can be random, or it can be, we can convert it into 70-30 or 80-20. It will depend how we split. Or we can use all 14 examples for training. So this is our result. In this way we can this precision recall F1, we have included this measure in earlier. So we can take these measures, precision recall F1. Now there are some issues, practical issues with the decision tree classification: underfitting and overfitting, missing values, and cost of classification. Tree pruning method address the problem of overfitting caused due to noise or anomalies generated during the construction of tree. Practically, for a small data set it is okay, but if data set some real data set, it is very difficult to allow the tree to grow at its full depth, because it will very complex. So we will perform the pruning. This pruning can be either pre-pruning or it can be post-pruning. So pruned trees are small, simple, and faster in classifying the new independent set or unseen test data set. So these two common approaches, pre-pruning. So in pre-pruning is stopping the tree construction prematurely while constructing the tree. Some significant measures, statistical significance like information gain, Gini index, can be used to analyze the correctness of split. Like we have decided some threshold value. If the gain of information gain value will be less than higher than this, then only we will perform the split, otherwise not. Statistical measures used to specify the threshold based on which tree construction can be stopped. Choosing an appropriate threshold. High threshold could result in oversimplified trees, whereas low threshold could result in very little simplification. So rather than performing this pre-pruning, because we don't know how this pre-pruning will lead, so we perform the post pruning. In post pruning approach, remove sub-trees from the fully grown tree. Sub-tree is pruned by removing its branches and replacing it with the most frequent leaf nodes. So this CART algorithm use cause complexity tree pruning algorithm, where cause complexity is a function number of leaves in tree and error due to misclassification. So this post pruning is more practical as compared to this pre pruning. This is all about decision tree algorithm. If you would like to ask question, then you are welcome. Otherwise, this is there are something, but the time is over. So I will, I would like to stop here. Yes, please. Hello. Hello.
Yes, sir.
Yes, if if audience have any question, then I'm here. I will be happy to answer. Otherwise, from my side, it's over.
Okay, sir. Dear audience, if you have any kind of query, please ask or raise your hand or by
Yes. Okay.
no questions from participant side. So yes, sir, one question is from Deepak Yadav.
Yes, please
Uh,
ask.
Good afternoon,
Good afternoon.
Dr. Dilip sir.
Yes, good afternoon.
So we have so many models in machine learning,
Okay.
and you have shown us one diagram that we have 80-20% principal rule for training and testing data sets.
Yes.
Is it compulsory for all the models to have
No, no, no,
20
no,
and
no.
80?
This is the one way. Actually, there is a cross validation, k-fold cross
Okay, okay, okay.
validation.
Then,
So,
sir, my question is that how can we decide the training and testing data sets depend upon the models?
the size of training, splitting of training and testing.
Yes, sir.
Yeah,
Splitting of training and testing
there is
sets.
no way, means there is no predefined rule of deciding whether we should consider. Generally, preferably, people use
Okay,
70% as a training, 10% as a
okay, okay,
validation, and 20% as a test.
okay,
This is
okay,
the general principle.
okay, okay, okay. Thank you, sir.
Otherwise, there is no way, means that empirically we will decide. Generally, we will consider, sometimes we'll consider 70, 10, 20, sometimes we consider 80, 20, and
Okay, okay,
empirically we will decide on which split our model is performing well, like this.
okay, okay, sir. Thank you, sir.
Yes.
Okay, thank you so much, sir.
Yeah, one
If,
Deepak Kumar Yadav has also raised hand. Yes.
Sir, I am Deepak Kumar Yadav, sir. I have just asked the question, sir.
Okay, okay. Thank you. Thank you.
Okay, thank you, sir.
okay, anybody want to ask any question? Okay, I think it's over now. Okay, thank you so much, sir, for your knowledge, for sharing your knowledge about artificial intelligence and machine learning. Thank you so much. And I would like to inform that all the participants should give their feedback and quiz. Link has been shared in the chat box. Please go to the chat box and give your feedback and as well as give the quiz. And one more thing, there is a break of half an hour. About 3 o'clock, we will start our second session, which is going to be start by 3 o'clock. by Dr. Anup Nandi sir, Assistant Professor, NIT Rourkela.
Thank you.
And thank you, sir. Thank you so much, sir.
Okay, thank you. Can I leave now?
Yes, sir. Yes, sir.
Okay, thank you very much.
And the topic by Dr. Nandi sir is supervised learning theory and application. We will resume after half an hour at sharp 3 p.m. So please participant, be on time. And kindly please give the feedback and quiz also. Thank you. Dear participants, today's first session has been ended, and we are going to start our second session at 3 p.m. sharp. There is a break of half an hour. Please join at 3 p.m. Thank you so much.